Welcome students. In this video we are going to see how to log in into Tinkercad and create a new experiment. Here, to log in into this Tinkercad in a classroom, the student needs classroom code and nickname for the student. Both of these details will be provided by the class teacher. Once you got the both details, you have to click join in the home page and select student join a class. Here you will be asked the class code. Here you have to type it, and you have to give your nickname here. Already I have created a nickname, a dummy nickname for this demo. And I'm logging in through that account. So once we got into this Tinkercad login, you will see 3D designs in the left hand side. It is for 3D printing. The next one is circuits. As we are going to design a simple Arduino base project, click the circuits. To design the circuit, click create new circuit. Here in this window you will see this is the workspace. The blank space which we see is the workspace. Next to that is here the components list. In components list you can select basic components or all components, and here let's go for the Arduino Uno. This is the development board which we are going to study in today's class. Drag and drop it to the workspace. Here in this Arduino Uno development board, you can see the USB port. In real world, to interface this board with laptop, we use this USB to serial converter IC and this USB port. And this USB to serial converter IC converts this USB data to a serial data and connect it to this ATmega328. The same TX and RX of this serial communication is connected to this D0 and D1 of this GPIO pins. We will be interfacing this USB port to the laptop, and in laptop we will use Arduino IDE to write the code, and through this USB cable we will write the or burn the code into this ATmega328 IC. Here we have the reset switch and the power supply circuitries, and here we have 4 set of connectors: first set, second set, third and fourth. The first set is about power supply, second set is about analog inputs, third set is about third and fourth is about general purpose IOs or GPIOs, which can be used as digital input output or PWM output, or some specific application might be there for those signals. For those purpose we can use this third and fourth set of connectors. Here you can see this wave symbol represents the PWM, and here this 0 and 1 were connected to the RX and TX pin of this IC. The same line is also connected to the USB port through this USB to serial converter. Apart from this, we have crystal oscillator, and this is a power regulator. Here we have 3 LEDs, this transmission LED, reception LED. These two will glow whenever there is a transmission or reception. Next we have this LED L, which is connected to GPIO 13. And one more LED is here. This is power LED. Whenever the power supply is given, this LED will glow. So in this first experiment, what we are going to do is we are going to uh, make this LED, which is connected in GPIO13, to toggle in a equal time duration. It is 1 second on, 1 second off. Like that, it should toggle. So to write the code for this Arduino Uno, you have to select code. So once you select the code, you will see a blocks. This you can program this Arduino either in block form or in text program. So you change that by selecting the drop down menu from block to text form. You change. Here in this we have two set of functions here. First set is void setup. This function, or this part of the code will be executed for the first time when the Arduino is started. This set part of the code will be executed only for one time, and this second part of this code is void loop. This part of the code will execute infinitely. It is similar to the in C language we used to write while one loop or forever loop, always loop, like this. This is called in different way. What is the purpose of this loop is this while one loop will be always true, so the statements whatever we write inside this loop will execute always. Most of the embedded devices will be running throughout the time until we give the power, so most of the codes will be written inside this while one loop. So here also this void loop is used in the same way. That means this set of 4 instructions or 4 statements will be executed infinitely inside this loop. So whatever we write inside this parenthesis will be repeated again and again. So first let us get back to the setup mode. Here in this function has two parameters. One is pin number and in what way we are going to use the pin number. This pin number 13 refers to the GPIO 13 here. D13 is referred as 13 over here, and output that we are making this D13 pin as a output pin. We are connecting to a LED, so that LED will turn on and off as a output. LED is an output device, so I'm configuring it as output. If I want to connect a switch to this, then I have to put input over here. Next is after configuring this pin number 13 as an output, the setup is done. Here in the always loop or loop part of this program, digital write. This is a digital pin, either 0 or 1 is going to be here in this IO ports, digital IO ports. So also we have configured it as output, so digital write is the function used for sending a data to this IO pin. Again we have to refer to the which pin I am sending, and then next is what is the value I have to write, that is logic 1 or logic 0. Logic 1 is referred as high, logic 0 is referred as low. So again I repeat, this is a digital pin, so digital, and we are sending a value into it so that it is write operation. So digital write, which pin we are changing, that we have to specify first, and next to that what value we are writing to that, we have to specify next. Okay, after doing this, I want the LED to be turned on for 1 second. That is given over here. This the value which we load here is referred to millisecond. There is a function written in the library background, so we don't have to worry about calculating all the delay times. Just type delay in and type the how much millisecond delay you need and give it over here. Next to that, after turning it on, so it will wait for 1000 millisecond. After that, it will come here and execute this. So now you can guess what it is going to do now here. Digital write, yes, it means it's going to send some value to that digital GPIO pin. And which pin it is? It is pin number 13. And what is the value? It is logic low or logic 0. After that, again 1000 millisecond delay, and it after 1000 millisecond, what it will do is, since it is a forever loop, it will go back to the first line inside this loop. So again it will make the IO pin as high and wait for 1000 millisecond, and again make it to low, wait for 1000 millisecond. Again it goes to the first line, again and again it will repeat the same un until the power is removed. So shall we check the execution of this? To check the execution of this, you have to click start simulation. You can see the USB cable is connected and the board is powered. The power is indicated in the LED, and you can see the pin number 13, the LED connected to the pin number 13 is blinking. This is a hello world kind of program. So your objective is to change the duty cycle of the if you consider this as a square wave, and uh, it has a 50% duty cycle. So if I want to change the duty cycle to 75% or 25%, how will you change? Yes, exactly. You have to change in the code. Like if I want to change the duty cycle, I have to change the delay time in the program. So let's see that in the CRO also. We have a CRO here. I'm giving the ground to the ground in the board, and pin number 13 to 13, positive of the CRO. Okay, let's start simulating. What is the waveform we are getting? See a square waveform. Okay, I have just increased the time period for the scanning of CRO here. So we see a square wave. See here, you forget about this part, it is not clear, but here you can see it is equal on time and off time. Here this one block refers to 1000 millisecond, and the second block refers to 1000 milliseconds. So on time and off time is equal. What I asked you to do is changing the on time and off time. For example, I'm changing this to 1000, 1000, off time 1000, and check how the waveform comes. Here you can see the LED glows extra double than off time, and the waveform also you can see on time is double than off time. Or you can say if this is 1000 millisecond, 1000 plus 1000, 2000 millisecond, and 2000 millisecond on time and 1000 millisecond off time. All changes saved. If you want to confirm your circuit is saved or not, check here, it will be mentioned over here. And after that, if you come out also, and later time you want to repeat or review your circuit, you can click this and click Tinker this, and your circuit will be back in the same state what you left. Let's run it again and see. Even the code is same, 2000 and 1000, and same waveform I am getting back. So after finishing my experiment, I just have to it gave a name by itself for this. I want to, for easy reference of mine, I want to rename the project. I rename it design name. I give it as a um, experiment 1, uh, blink experiment, and save changes, and you can see the name is changed. That's all with this experiment number 1 demo.